So let us just go through what we did in yesterday's class. We practiced an algorithm to determine whether a number is prime or not. Okay, you people by now you know what the prime number is. It's a number which is only divisible by 1 and itself. Okay, and any number that is divisible by other number 1 and itself, then that will not be called as a prime number. Let's suppose we have an example 6. Okay, so we will find out the factors for 6, the numbers which can divide 6 completely. So as you see, 6 is divisible by 2, right? 2 1s are 2, 3s are 6, right? So 2 completely divides 6, and then you also have 3, which divides 6 by 2 times. 3 1s are 3, 2 times is 6. So other than 1 and other than 6, that is the number 1 and number itself, other than these two numbers, there are other two factors, that is 2 and 3, which divide 6 completely. So with this we can say that 6 is not a prime number. Same for 10 also, right? You have two other factors, 2 and 5, that divides 10 completely. Therefore 10 is not a prime number. But when you see 13, and you have a lot of prime numbers, you have 5, you have 7, you have 11. For these numbers, you try finding out the factors. You won't find any number except for 1 and the number itself, right? So only there we can say that the number is prime number. And we also wrote an algorithm for that. See, the step first, always the first step is going to be start and the last step is going to be stop. We have to add this. We have to stop it. Okay. This also. Okay. So we took the second step was we took the input. First thing is we need to take an input. We need a number for which we need to find whether it is prime or not. Then we set I to 2. Okay. So I hope people who attended yesterday's class, they will understand why we are initiating it. We are initializing I to 2, not why not starting it with 1, right? Anyone from yesterday's class, can you tell me why did we set it? Why did we initialize it to 2?
Because he divided by 2.
Because we know, we know our condition is, we know that any number that will be, definitely it is going to be divisible by 1 and it is going to be divisible by itself. So whenever we run a loop or we take a range, that will exclude the first 1 and will exclude the number itself. That is why we are not starting with 1, we are initializing it to 2. Okay. Then what we do is we run through a loop, we have a condition. Okay. Whenever there is a single condition, just keep in mind that this will be a while loop. Okay. We can use a while loop whenever there is only single condition we need to check. So until and unless this I is less than or equal to the half of the number that we have taken, we'll keep repeating some steps. Okay. So that is nothing but what we'll do is we'll go to step 5 and 6 until and until this condition satisfies. Step 5 and 6. Okay. What we can do is we can make this as a single step. Okay. One thing we can do, we can reduce complexity. We can make this a single step. This is step 6. This is step 7. Okay. So until and unless this condition satisfies, what we'll do is we'll go to step 6. We'll go to step 5, else we'll go to step 6. Okay. And then let's go to step 6. If num mod I is equal to 0, then you go to step 7. You go to step 6. both the places we go to step 6. Quickly, I will take one example. Okay. See, this is what we did yesterday. Let us suppose take an example. Our number is 13, input number is 13. So the range that I'll have to take, that will start I from 2, right? I will be first iteration. Okay, we are starting the algorithm. We have taken input number as 13 and we are setting I to 2. Now we'll check condition whether I is less than or equal to n by 2. For simplicity, let us go until n itself. Okay, so we'll check I less than or equal to n. So I is 2 and our number is 11. Okay, we'll take this as 13. 2 less than 13. Is 2 less than 13? Yes. So what will I do? I'll go to next. I'll go to this step number 5. I will find the modulus. And also yesterday I explained about what is modulus and what is dividend. You need to understand the difference between these two.
Yes.
Okay. You need to understand the difference between these two symbols. This is nothing but mod operator. Okay.
Which gives the whole number as a remainder.
Okay. This gives you the remainder.
Whole number as a remainder.
Whole number as a remainder. And as far as this is concerned, this will give you
Decimal as a remainder.
whenever you want to skip a number. Okay, at that time you can use division. Division basically will give you quotient itself, but not integer value. Okay. Division operator. This will give you quotient itself. Let us take a few examples and understand this, because this is very important. Even in our next algorithm that we're going to solve, we'll be needing these basic things. See, let us suppose I want to find 12 mod. Okay, instead of using percentage symbol, I will write it as mod. Okay, 12 mod, let's say 5. Okay, so what is this going to give me? I'll divide 12 by 5. I'll get the remainder. Okay, so 5 ones are 5 2 times is 10, and the remainder is 2, right? Okay, and there is one formula also. Okay, you can make a note of this. At some point, our division will fail. Like for negative numbers and all, we won't be able to find proper mod. So there is a formula. Just keep a note of this. If we have A mod B, so this is going to be A minus B into floor value of A divided by B. Let us check. Okay. Let us take the same example. Let us take 12 by 5 itself. Just replace the values at its position. Okay. So we are taking 12 mod 5. So 12 is A and 5 is B. So we have A minus B. We have 12 minus B is 5. And then we have multiplication. Floor. I'll tell you what floor value is. See, when you divide two numbers now, so we'll ignore the decimal value, and this function will return the closest value. Let's suppose if the value is 5.2, so this will give you 5. If it is 5.7 also, it will give you 5 itself. Okay, for positive integers, this is how it will work. So we have 12 by 5. Now solve this. Keep 12 as it is, minus 5 as it is. What will the floor value be? 12 by 5. What will it be basically?
2.
2, right? 2 point something, 2.4 or something. But
yes, sir.
Floor value
is 2.
Okay. So now you multiply 5 with 2. 12 minus. Okay, for simplicity, you can add this here. don't want things to get confused. These parentheses will give you, it will make more sense. Okay. First you solve first you solve for floor for floor of A by B. Then you multiply that with B. Finally, you subtract that from A. Okay, that will make things easy. So 5 into 2, that is 10, and 12 minus 10 is
2.
See, this is one kind of a formula, just for practice purpose. Okay. In our when we write actual programs, you need not calculate this. The system itself will give you return you the correct values. But to understand, I have put in this thing. You can remember the formula. Just make a note of the formula to find out. Okay. So whereas what will 12 divided by 5 give me? This will give me a value as 2. Okay. This is not a reminder. 5 ones are 5 2s are 10, right? So it will be 2.4 something. We will return 2 as a quotient. Okay. Now in our programs, what basically we use mod for is for reminder, and division operator why we use is, let's suppose I have a number 1 2 3 4. Okay. Now I want to eliminate the last number. Okay. The next program that we are going to solve will be using this there. I want to eliminate 4. I want only 1 2 3. So what I'll do is I'll divide this number by 10. Okay. When I divide this number by 10, what will the answer be? Definitely it's going to be 1 2 3, right? If you remove the decimals, 10 one time is 10. 10 1 2 3 4 time is 1 2 3 0.
1 2 3.
1 2 3 0. 10 into 1 2 3 is 1 2 3 0. Decimal dot, you will skip 4 there. So the answer you get is 1 2 3. Next, again, let's suppose I don't want 3 there. Okay, I want to remove 3. What I'll do? I'll divide again by 10. What will the answer be? 12. Again, let's suppose I want to divide it by 10. Okay, I want to eliminate 0 from there. So I'll divide it. I'll get
1.
1, right? 10 ones are 10. Again, finally, when I do, I'll get 0. Okay. So this is why this is the purpose for which we use divided operation, and percentage symbol, that is mod, we use to find the remainder. Now both these operators we are going to use in our next program. Okay, I hope things are clear. Where were we? Let me just remove this off. Okay. The first iteration, right? So I less than or equal to n. Okay, and I less than 2 is less than 13. Yes, I'll go inside. I'll go to step 5. In step 5, I have 2 things. What I'll do? I'll check num mod I is equal to 0. Matlab what? If I divide my number with I, that is, I is going to be the other numbers, like the range. I'll check if 3 divides my number. No, then I'll go forward. I'll go to 4. I'll check if 4 divides my num, that is 13. If no, then I'll again iterate. I'll go to 5. I'll go to 6. I'll check if I find any one number that completely divides my num, that is 13, then what I'll do, I'll directly go to step 6 and I'll print that the number is not prime. Okay, but after iterating completely from right away, starting from 3 and going to the end, the last but 1, that is 12. Okay, if I don't find any number which is dividing 13, then I'll say at that time my I will become that will be equal to n. Okay, at that time I can say that see boss, I did not find any number which is dividing 13 completely, therefore 13 is prime number. So that is how we loop through each of the items, iterations, one iteration at a time. So here I'll check num mod I is equal to 0. My number is 13 mod 2. Num mod 2, 13 mod 2. What will be the remainder? Okay, so 2 ones are 2 6 are 12, right? And the remainder will be
1.
1. It is not equal to 0 as per our condition. It is not equal to 0. So what we do? We go to
Step 6.
okay. See, it is not equal to 0. So we'll still remain in this equation itself. Second thing, what we do? We'll iterate I. I was 2. I becomes 3 in the second iteration. Okay? Iteration number 2. Number is still 13, but I becomes 3. It is we are incrementing I by 1. So I becomes 3. Now again check this condition. We are going to step 4. Okay, after this step 5, we are repeating this. Step 4 and 5 is getting repeated until and unless this condition is true. Now we'll check 3 is less than 13. Yes, 3 is less than or equal to 13. Okay, we'll not use equal to because we are eliminating the number. We'll not check for 13. If the number is 13, we will not go up to 13. We'll go only up to 12. Why? Because we don't want the number itself and 1. Numbers between these two we'll take only. Okay. So we see 3 is less than 13. Yes. Then find the modulus. Find the modulo of 13 mod 4. If it is 0, then you directly skip. No, here it is not 0. It gives me 1. 4 ones are 4, 3s are 12. Again, I get reminder 1. So what I do? If it is not true, then go to step 6. Else, I'll put it down. No. Go to step 4. Okay. You go to step 4 and you check this condition. In the else condition, when you don't find 0, you'll go back to 4. Next third iteration. I becomes 4. 4 less than 13. Yes. You find the modulo of 13 mod 4. Again, you get a reminder 1. Okay, so in this way, you complete the iterations right away, starting from 3 and till 12. You will not find any number for which you will get the modulus as 0. Okay, so finally, when we reach I as 12 and 12 less than 13, okay, and 13 mod 12, even this is not giving me 0. So next incrementation, I becomes 13. Now you see here, when I is 13 less than 13? When we come back to step 4, final iteration. Okay, final iteration. Is 13 less than 13? No, 13 is not less than 13. So what we do? We'll go to step 6. Okay, we'll go to step 6. And in step 6, what do we have? We'll check condition. This condition is satisfying now. That is, we have reached to the num iteration. 13 is equal to 13. So finally, what we'll do? We'll print num is prime. I hope you guys understood this. What you can do is, the people who are new today, who were absent for this class, you take this algorithm. Okay, I've put this in the group also. Take this algorithm, take a few examples, and try it solving in this way. Okay. When you solve it in this way, you will understand the algorithm properly, the conditions and all. So modulus thing is clear, right? How we use mod operator.
Yes, that's.
So now let us move to our next algorithm. Okay. So we'll talk about reverse of number. Algorithm to find the reverse of a number. Now, let us first see how we can achieve an algorithm. Let us not directly go into the algorithm. Let us take a few examples. Okay. Let me say my number is 1, 2, 3, 4, 5. Yeah. This is my number. I need to find the reverse. At the end, what is my output?
5, 4, 3, 2, 1.
Input is this, and I'm expecting the output of my algorithm to be, that is the reverse, 5, 4, 3,
5, 4, 3, 2, 1.
Okay. So how can I do that? Okay, how can I do that? See, here we are not using arrays. Okay, we have not yet come to the concept of arrays. Okay, so if we have arrays now, we'll have each element at one index of the array. Okay, you can assume it to be one single box. Okay, there will be 5 different boxes, and in each box, one value will be stored. In that case, we can use pointers or we can loop through and we can store the numbers in reverse order. We can take one extra number, okay, and we can do that. But since this is single number, we are not using arrays, this is simple integer number, we have a different approach. As I mentioned, we'll be using mod operator and the division operator both here to find out our reverse number. Okay. Now, first thing what I told you is, let's say we have 1, 2, 3, 4, 5, right? The first number, what is the first number that I am supposed to get?
5.
Five.
My reverse. I need
Five.
5, right? So, as I told you,
नेक्स्ट पेज है अभी बहुत ज्यादा खराब.
okay. So, as you heard, as I told you, in order to get 5, I told you like we'll be skipping one last number. So, in order to skip 5 or to remove 5 from this, what did we do? I took an example of 1, 2, 3, 8, right?
We have to divide by 10.
I will divide this by 10. Okay. So that this will give me value as 5. This is one step. Okay. I'm going to divide that. And I'm also supposed to get the mod operator. Okay, I'm supposed to get the mod also. Just give me a second. So reverse is this. In order to find the remainder, okay, let us say this is my remainder. Okay. We'll keep iterating this. Okay. In first iteration, this will be the number and we'll get the remainder. And then next what we do is, we'll multiply this with reverse. See, when you divide by 10, you are eliminating a number, right? Again, when you multiply, you will get back the same thing. You got my point? See, you have 1, 2, 3, 4, 5. You're dividing it with 10. So you get 1, 2, 3, 4. Next, I want to get back 1, 2, 3, 4, 5. So what will I do? I'll multiply this number with 10. What did I get? I got 1, 2, 3, 4, 0. Right? Are you guys? I multiply.
Yes, 1, 2, 3, 4, 0.
Finally, what is missing? What is missing now?
5.
See,
5.
when I multiply with 10, I will get 1, 2, 3, 4, 0. Right?
Remainder.
But what is missing? Missing is
5.
5. So 5, from where will I get? I'll get it from remainder, right?
Yes.
See, nothing but my number. Right? This is nothing but my number. And I'll multiply this with 10, and this is supposed to be my remainder. Let's suppose this is reverse number. Okay. And this is how we are supposed to find out the formula. So this is the formula, okay? You need to keep iterating this. The value of reverse will keep changing. Okay. Until and unless the condition, like we iterate through all these 5 things. This is one step that we'll do. Reverse into 10 plus the remainder. Okay. And one more thing is finding out the remainder. First thing is this. Finally, once you have the reverse, see, now we had 1, 2, 3, 4, 5. I need to eliminate 5 and I want 4. So what will I do? From the number, okay, number is 1, 2, 3, 4, 5. I don't want 1, 2, 3, 4, 5. I need only 1, 2, 3, 4. So what will I do? I'll divide the number by 10 again, right? So this will give me 1, 2, 3, 4. Next time when I loop it, okay, I'll have 1, 2, 3, 4. When I divide it by 10, I'll get only 1, 2, 3. So basically, what will I be doing? This will be in my num. Okay, this is one step also that I'll be doing. Okay, I'll keep reducing the number at each iteration. First time, my number will be 1, 2, 3, 4, 5. Now, I'll eliminate 5 from it. So at that time, it becomes 1, 2, 3, 4. And then it becomes 1, 2, 3. And then it becomes 12. Then it becomes 1. And finally, it becomes 0. Okay. So this is how we are going to proceed. Now, let me show you the algorithm. Okay. we'll take a few examples and we'll try solving it. The first step, always the first step is going to be start, right? So I missed that. You guys can add it. So start and stop. First thing is we need the input, right? We need the number for which we need to find the reverse. So first thing is we'll take the input as first step one is we'll take the input number. Next, as I said, we'll need to have a variable to hold the reverse values. Okay, and I hope you know what variables and what these values are. The variable is nothing but it will hold on this number into it. Okay. So we'll set reverse to 0. Initially, let us have reverse as 0. Okay, there is nothing into it. It's just simple 0. And the condition that I told you, okay, this num, we keep reducing it, we keep dividing it. First time number will be 1, 2, 3, 4, 5. At the second iteration, it will be 1, 2, 3, 4. Third iteration, it will be 1, 2, 3. Next, it will be 12. Okay, next it becomes 1 and then it becomes 0. Okay, so final condition is 0. I need to, keep repeating it until and unless my number becomes 0. Okay, only then I can loop through all of these numbers. So for that reason, what I do is I'll have a condition where I'll check if num is greater than 0 until and unless number is greater than 0 for these 5 iterations. I'll go to step 4. And in step 4, I have 3 things that I'm doing. Okay, first thing is I'll find the remainder. Second thing, as you saw here, we found out a formula kind of thing. Reverse will become reverse into 10 plus the remainder. Okay,
Yes.
that will be our formula to find the reverse. And finally, before exiting, before going to the next iteration, we'll reduce our number by 1. We'll remove 1 digit from it. How do we do that? We'll do num is equal to num by 10. Okay, so okay, let us start with the iteration. The first iteration, you guys can also practice simultaneously. Okay, first iteration, I'll come. Let me say I have my number I've taken. Input number is 1, 2, 3, 4, and 5. Second step is I'll initiate or initialize this variable reverse to 0. Okay. Next, I'll check this condition. I'll be iterating or I'll perform something, a few statements. I'll execute a few statements until and unless this condition is true. Okay. So number is 1, 2, 3, 4, 5, and that is greater than 0. Yes, the number 1, 2, 3, 4 is definitely greater than 0. So what am I supposed to do? I'm supposed to go to step 4. Okay. So what does step 4 say? It says you need to execute these 3 statements, 3 lines. First thing is you set the remainder. Matlab you find the remainder. How do you find the remainder? By using num mod 10. Okay. So the number is 1, 2, 3, 4, 5 mod 10. So what will be the remainder? The mod value is 5, right? The remainder is 5. Right, guys?
Yes.
Okay, so we got the remainder. Next step is you calculate the value of reverse. Reverse value will be reverse into 10. Initially, reverse is 0. You multiply with 10, that becomes 0. Plus the remainder 5. So initially, first thing is we'll get the last digit, that is 5. Right? And next, before going to the next iteration, we have one thing to do. What will we do? We'll reduce the number. Now 5, we are done with 5. We don't want 5 at the last. We want only 1, 2, 3, 4. In the next iteration, we want only 1, 2, 3, 4. So what we'll do? We'll divide this number by 10. When we divide it by 10, this 5 gets eliminated. We'll have only 1, 2, 3, 4. Okay. So now, next, again, I'll go to step 3. I'll check if num is greater than 0. After executing this step 4, I'll be going to step 3. I'll check if num is greater than 0. 1, 2, 3, 4. Is it greater than 0? Yes, definitely it's greater than 0. So I'll again come back to step 4. I'll execute the statement. So what I do in the second iteration is my number, remember
Okay.
this, number keeps changing. So in step 2, num is 1, 2, 3, 4. So again, you find the remainder. First thing is you find the remainder. So 1, 2, 3, 4 mod 10. What will the answer be?
Oh,
The remainder is 4. 10 ones are 10, 1, 2, 3 times is 1, 2, 3, 0. Remainder is 4. So that will give you value as 4. Next, you calculate reverse value. Reverse will be reverse into 10 plus remainder. What was reverse from our first iteration?
5.
5 into 10 plus the remainder that you got here. 5 into 10 is 50 plus the remainder that will give me 54. So I'm done with last two numbers. I've got 54. Now before I go to next iteration, I'll have to reduce the number. I'm done with 4. I don't want 4 now. I want only 1, 2, 3. So what I'll do, I'll divide this 1, 2, 3, 4 by 10 so that in the next iteration, my number becomes 1, 2, 3. Okay, right away starting from 1, 2, 3, 4, 5 till I'll have to go to 0. Until and unless my number becomes 0, I'll have to keep doing this. Now again, since 1, 2, 3 is again greater than 0 from step 3, I'll go into step 4. So step 4 again, what do I have? Step 3, I have 1, 2, 3, find the remainder. So remainder of 1, 2, 3 mod 10. You can use the
Okay.
formula also. Okay, that will give you remainder as 3. Then calculate reverse. Reverse from the previous iteration was 54. You take 54, multiply with 10. Just populate values here in the formula. 54 into 10, right? Plus the remainder is 3. So that will be 54 into 10 is 540. Okay, plus 3, 543. So we get the last 3 digits. Now again, I don't want 3. I'm done with 3. So I want to eliminate that. So what I'll do, I'll divide the number by 10. Okay, so 3 is eliminated. I only have 12. Since 12 is greater than 0, again I'll have to loop through things. I'll have to go with another iteration. So in next iteration, I'll check the remainder. 12 mod 10, that is 2. Reverse, in previous number, reverse was 543. So start with 543, multiply with 10 plus 2. You will get the last 4 numbers. You'll get these 4 numbers. And finally, I'm done with 2 now. I'm done with 2. I don't want to, so I'll divide the number with 10. I'll get 1 as the quotient value. 12 by 10 I'll get 1. Since 1 is greater than 0, again I'll have to go through one more iteration. This condition has not yet failed. 1 is greater than 0. I'll loop through once again. I'll check 1 mod 10. See, now if you directly see 1 mod 10 without using this formula, we may fall, we'll get false answer as 0, right? So 1 mod 10 is you try, what we do is, we'll have 1 in the center. We'll divide it with 10. Right. So what we do, we'll put a 0, we'll put a dot, and we'll add one number here, and we'll say like this is 10 ones are 10, and the remainder is 0. Right. So from here we get that the remainder is 0, but actually it is not. So because of which, we'll have to use the formula. When you use the formula, you will get the correct value. That is 1 mod 10 is 1. Okay. You can substitute here in the formula itself. You will get 1 as the mod value. Reverse in the previous iteration was 5432. You take that. Okay. You multiply with 10, and then you add the remainder. Finally, you get 54321. And now, since again, since I'm doing it num by 10, so I'll do that. I have 1 by 10, but 1 mod 10 is 1, but 1 divided by 10 is 0, right? We'll get 0.1, but here in integers, we are eliminating the decimal values, so that will be 0. Now my num, finally my num is 0. I'll go back to step 3 again. I'll check num greater than 0. Is num greater than 0 here? 0 is not greater than 0. That means I'll be going into else statement. If this condition is true, I will execute this. Else, I will execute this. This is how the conditional statements work. If this condition satisfies, you execute the statements within this condition. Else, you go to else part and you execute this statement. So since the condition failed here, we'll go to step 5. What does step 5 say? Step 5 says print reverse. And finally, what was reverse? Reverse was 54321, which is exactly what we wanted as an output. Right? Any doubts?
sir.
Let us take one example. Tell me one example number, okay? We'll take that and we'll try solving it. Give me a number. Any number.
275.
2?
275.
275.
Yeah.
Okay. So my number is 275. The first step is you start, and then the first step is you take the input. I have taken the input as 275. The second step is I want to initiate a reverse number to 0. Right. So yeah, this is also done. Next, check condition if num is greater than 0. This is we are going inside iterations now. We'll iterate or we'll repeat until and unless the condition satisfies, or until and unless the condition is true. So iteration 1, what are we supposed to do? Is num greater than 0? First, let us check here. Is num greater than 0? 275 greater than 0? Yes. So you will be going to step 4. After step 4, say, first find the remainder. Okay. First find the remainder. So reminder will be num mod 10.
Mod.
So what is my num? 275.
Mod 10.
So what will it return?
5.
10 ones are 10, 27 times 270. Remainder is
5.
Right. So we found the remainder. Next thing is, next step to execute is find the reverse. Reverse is reverse into 10. Initially reverse was 0.
0.
Right. We are starting from 0. So reverse is 0. You multiply that with 10. Add the remainder finally. That is 5.
5 equals 5.
So let us have this so that we can have the conclusions. So 0 into 10 is 0 plus 5. That will give me reverse value as 5. Let me have this here. Reverse will be 5. Finally, before I go to the next loop, I want, since I'm done with 5, I don't want 5 now. I want number 7 to print. So what I will do, I'll eliminate 5. How? I'll do num by 10. I'll divide 275. My num becomes, num will be equal to the number divided by 10. What will the answer be?
27.
27. Right. So we are done with first iteration. Okay. Now we'll again check if the condition satisfies. What is my num? 27. Is 27 greater than 0?
Yes.
Yes. So then I'll have to repeat one more iteration. I'll have to go into one more repetition. So let us say it is iteration 2. Now in iteration 2, what am I supposed to do? First thing is find the remainder. So remainder will be num mod 10. What is my num? For iteration 2, num is 27. So this will be 27 mod 10. 27 mod 10, what will it give? 10 ones are 10, 2 times is 20.
7.
Remainder is 7, right? See, first we got 5, then 7, then in next iteration, definitely we'll get 2 as the remainder. So now we have the remainder, calculate the reverse value. Reverse into 10 plus remainder. From the previous value, reverse was
5.
5. So that will continue. See, we are not setting reverse anywhere. Reverse is, as and you go into the iterations, reverse will get, it will be updating. We are not setting it to start value. We have written set here. That means every time we go into a loop, new reminder value will calculate. But for reverse, it will keep updating. It will keep updating. In the previous iteration, reverse was 5. Now reverse will become 5 into 10 plus the remainder. Remainder is 7. We add 7 here. Sorry. We add 7 here. So 5 times 10 is 50. 50 plus 7 is 57. So you get these two numbers. Now I'm done with 7. I don't want 7. I only want 2. So what I do?
27 divided.
I divide 27 by 10. I'll get remainder as 2. Now is my 2 greater than 0? Yeah, it's definitely greater than 0. So I'll have to go into one more loop. One more iteration. So this is 3. Reminder from my previous iteration was, what was the reminder? 57, right? Okay, not the reminder. Num value from my previous value. It was 2. So take 2 mod 10. See, if you find difficulty in finding 2 mod 10, you can use the formula. What does the formula say? A minus B. A is 2 minus B is 10 into floor value of A divided by B. So 2 remains 2, 10 remains 10, and the value of floor 2 by 10. 2 by 10 will be
2.
Right. Will it be 2? 2 divided by 10. 0, right?
Yes, 0.
Since we are talking about decimals here, 0. We'll have like 2 inside, and then 10. 10 cannot divide 2, so we'll have a point 0 and we'll have a decimal point. Then we'll put 0 inside. 2. Okay.
Yes.
2 5 times is 10, right? In that way. But since we're eliminating decimals, quotient will be 0. So we'll have 0 here. So 10 into 0 is 0. 2 minus 0 is 2. So we'll get mod value for this as 2. You use the formula and you'll get the correct mod value. Okay. So now we have reminder as to calculate the reverse. The reverse from previous step was 57. So 57 into 10, 570 plus the remainder. That will be 572. Okay. And now definitely I'll have to divide the num. Num was 2. Since I'm going from within the like iterating through each statement, I'll have 2 by 10. So 2 by 10. 2 mod 10 is 2. But 2 divided by 10 is
0.
0. Okay. So now what is my num? Num is 0. I'll again go check in the step 3. Is num greater than 0? 0 is not greater than 0. So I'll go into else condition. What will I do? I'll go to step 5 finally, because since, see, what we talked about is the number value, the number that we take will have to move from its actual value up to 0. From num to 0. Until then we'll have to iterate. So finally now the number is 0 and it is not satisfying this condition. So we'll print the reverse value. Now what was reverse here by the end of third iteration?
572.
Reverse was 572. So we'll print that. And then finally we'll stop. Right.
Okay, sir.
So this is how you write an algorithm to reverse a given number. But when you talk about strings, that is characters, okay, at that time these will change. Okay? At that time when we get introduced to strings and all, at that time we'll see how we can reverse a string, how to reverse an array. Those will come in future classes. For time being, this is about reversing a number. Okay, you can practice this algorithm. The only thing is you need to keep in mind is these are the main 3 things that you need to do. There will be certain algorithms where you need to like know what you need to do. Like we have three statements. You cannot leave this. You cannot skip this. You cannot write your own stuff and like reverse a number. So these are pre-formed. So you need to follow this. You need to remember these steps. First thing is we need to eliminate number. This number we need to eliminate, because of which we'll find the modulus. Next thing is we need to reverse the number. We need to add those things. So for that thing, we have this reverse statement. Finally, I'm done with this number. So I want only 1, 2, 3, 4 in my next iteration. What I will do, I'll remove that from my number by dividing with 10. So the number keeps on changing. In first iteration, it will be 1, 2, 3, 4, 5. In next iteration, second iteration, it becomes 1, 2, 3, 4. Third iteration, it becomes 1, 2, 3, 12, 1, and finally it becomes 0. Right? First, when we began, we had number of this. Then it became 1, 2, 3, 4. Similarly, finally we reach 0. You can take a few examples and you can practice this algorithm also. But the main intention in bringing this algorithm was to introduce you to the mod operator and the divisor operator. Which places will use mod operator and which places will use the divisor operator. And you can see how we are using the loops conditions. And you can see here there is no incrementation part we are doing. Okay, in our previous algorithm, we were incrementing I, right? We had to go from let's suppose we had 13 as a number. We had to loop through, like iterate through each of these numbers. First 3 and then go to 4. If 3 does not divide 13, then go to 4, then go to 5, then go to 6. Here there was like incrementations. We had to move from one number to the other number, because of which we use this I variable. And here the best suited loop is for loop. In coming classes you will understand these two. Okay, what's for loop and what's while loop. For repetitions, for iterations, repeating things, you use loops. So for this reason, since we had iteration, incrementation, like from 3 need to move to 4, then move to 5, then to 6, then to 7. We used for loop here. When you execute this, when you write a real Java program, okay, you will be using for loop and will be executing this. But here, since we did not require any incrementation in our algorithm, so we have only one condition to check. If this condition satisfies, execute a few statements. If it does not, then execute some other statement. This is direct for a straightforward thing. So for this algorithm, we'll be using while loop. Just keep it in mind. Whatever algorithms we are writing now, okay, in future classes, we'll write pure Java programs and we'll execute them also. We'll see how the outputs will. We get the outputs. So for this, we'll be using while loop. For the other thing, we'll be using for loop. Okay. So this is about the second program, that is the reverse of a number. Is it clear, guys? Do you have any questions?
Yes, sir. Clear.
Clear.
We'll end up the class in 10 minutes or so. We'll just discuss about the next program, and in next class you can come up with we'll start with your inputs on this. Okay. So the next program that the algorithm that we're going to write is about factorial of a given. Any one of you, can you tell me what a factorial of a number is? How do we find a factorial of a number?
Factorial is the sum of all the positive integers. Multiplication of all the possible positive integers.
Not sum, multiplication, right? Multiplication of all positive integers. All, you need to be a bit more specific. All positive integers. What do you mean by all?
It is a factorial of 5. It is 5 into 4 into 3 into 2 into 5.
If we are fine, let me write it here. Example, if we are finding a factorial, I'll write it in a short form, like fact. If I'm finding fact of 5, that is factorial of 5, what am I supposed to do?
Multiply 5 into 4 into 3 into 2 into
5
1.
into 4 into 3 into 2 into 1. So I'll go till 1. Okay. For better understanding, I'll write this in reverse order. I'll start with 1. Okay, since we are looping through things, right? We will be looping things. I'll start from 1 itself. Okay. I'll increment the 1 value, and I will go until I reach this
5.
5 value. So this is my num value. Let us suppose the number whose factorial I want to find is 5. So I'll increase first. I'll have one iteration variable here. Okay. So I'll initialize it to 1. Initial value will be 1. First time I'll only have that 1. Okay. Next I'll multiply it with, I'll iterate 1. 1 plus 1. What will it give me? 2. Next what I'll do? 2 plus 1. 3. Again I'll add 1.
4
Again,
plus 1, 5.
Now I have reached 5. Now my I variable, I'm talking about I. Okay. First time I was 1. Okay. Second place I was 2. Third place I was 3. Fourth place I was 5. Now I is 5. Give me a condition. Okay, since I've made it clear, give me a condition that you tell. Until this condition, you run this. Once the condition fails, you just stop it. So what can the condition be?
I less than m. Num, I think.
I until and unless I is less than
num.
Right? See, now I is 5, less than or equal to. See, if you take less than
Less
num,
than or equal to.
you are excluding num. Okay, when you take less than num, you are excluding this thing. Less than means 1 less than this num. If it is 5, it will only execute up to 4.
I 0, then it's
So we need to take is equal to also here. Okay. So right away starting with 1 and until and unless I reach it to the num value, that is 5. I is equal to 5. Now next I is at 5. Next iteration I will become 6. This condition will fail. Right. So I will stop here itself. Understood?
Yes, sir.
Okay. I'll initialize for this thing. How I wrote here 1 and then 2 and 3. For that we'll use one more variable. What we do? We'll use a variable called fact and we'll initialize it to 1. Okay. I'm just telling you high level thing. You prepare an algorithm and tomorrow you show me. Okay. Don't go and search and directly get it from internet or things. Just understand. I have initialized things for you. I have given the condition also. Okay, I'll put a condition as this is your condition. Until and unless this condition satisfies, you will have to execute few steps. That steps you will have to find out. And initialization, I have given you one fact number as 1. Finally, you are going to print this number. Okay. Final step, you need to print fact. Whatever you will be in the fact variable, you need to print that. Okay, that is one thing. Initially, it will be 1. Finally, after executing statements, what will be fact value? You need to tell that. Okay. And initially, I is 1. Okay, you are starting with 1. And this is the condition for which you need to execute a few steps. Now that step that you need to execute, that you will have to write. This part, you see, you execute and you try to write it. This fact value you will have to update. See, again, I am giving you one more clue here. You will have to update this fact value. I used this update word somewhere here. Reverse. We are not setting new value to reverse. We are updating. First time reverse was 5, then it became 57, then it became 572, right? But here, reminder, we are setting it every time, new value. Whereas for reverse, we are having the same. So somewhat similar to this, formula itself, you will have to prepare. That will give you fact value. For each iteration, it will give you factorial. Okay, will you guys do it?
Yes.
Okay,
Yes, sir.
tomorrow, take a few examples, try to find the algorithm. See, the solution is at your fingertips. Okay, so you can directly go search Google and you can show the answer. The better thing is try creating or try writing the algorithm by yourself. If you get wrong also, no worries. If a few steps are missed, we can go through your algorithm and we can correct, we can modify. If you make mistakes, only then we'll learn. Directly, if you copy paste, we'll not understand this. And this part is very important. You need to practice, solving the algorithms in this manner. Once the algorithm is ready, you need to do this. When you start doing this now, even though if your algorithm is wrong, you will rectify your mistakes from identifying things. You will see, okay, now this was this, reverse was, let's suppose I made a mistake of not adding, reminder here. Okay, I just told like reverse into 10. So when I keep doing these things, I'll be missing that one particular thing will be missing. 0 into 10 initially it was 0. No, not 0. I need to get reminder 5. Okay. So let me see if I'll add the reminder here and let me check. So when I do that, I'll get the correct answer. So okay. This is how it's supposed to be. So that way, when you solve it in this form, okay, wherever you get mistakes, you know what you need the output, right? You need the reverse of the inputted value. So wherever you make mistakes, you'll identify, you'll get that mistake from these things, and you will rectify you will recorrect your algorithm. Again, you will check. So this is how you will form your algorithm. Try, forming an algorithm for factorial. And in tomorrow class, let us solve factorial, and we'll bring up some more algorithms. I'll bring some more factorial algorithms. We'll have Fibonacci series. Okay. And let's see, we'll try to find a few more algorithms. And once these things are clear, maybe from next week, we'll start Java itself. Okay.
Okay.
So from next week, we'll start Java. We'll introduce what Java is, where all it is being used, why we need to learn Java, its syntax, how we install it in our systems, configuring a few things, and then right away starting with our first program, and then going through with the basic syntax. And there are a couple of things that we need to learn. The basics. Once we are ready with the basics, we'll execute these algorithms itself. Once we are ready with the basics, once we are done with if condition, the conditional statements and the looping statements, we'll try solving these. So we'll write programs to find the solutions to these algorithms itself. Okay, maybe 3-4 algorithms, and we'll dive into it. So then from next week, we'll start right away with Java.
Okay.
Clear, guys? So I think it's only one way it's communicating. So who is it? Is it Sudha?
Yes, sir.
So I would like even other participants, if you can communicate. If we have a two-way communication, it will be easy. Even we'll get to know like the people are understanding. So right away, starting from the session, and if you people keep quiet now, will not understand. Like if you got the answer for the session, useful to the people. There is nothing to shy here. Okay, it's not like we need to speak in English itself. We can speak in our native languages also. Okay, but we need to have a proper two-way communication. Only then, we'll be in the right direction. Okay, guys. So if things are clear and if you have no doubts, we can end today's session.
Okay.
Let me know. Let me put this all with them. Put this in the group. Okay. So shall we end the session now, guys?
Yes.
Was the session
Thank you
useful?
so much.
Need your feedback, guys. Was the session useful? So that next class
It's very
we have
useful.
some
Thank you.
we have some motivation, continue. See, we are not professional teachers. Let me tell you this. Okay? Let me make this clear from now itself. We are not professional teachers. Okay, we are industry people. We try to tell you things that will be useful in when you attend your interviews and all. Most of the knowledge would be practical wise, not complete theory thing. It would be most of the things would be practical. Okay. Okay
Okay.
then, guys.
Thank
That's
you.
it
Thank you.
for your patience. Let's see tomorrow we'll connect back. Okay. And have a great day. Okay. Guys. Take care.